So in Euclidean geometry, when I have two lines, any two lines, here I have line R and line S, any two lines that are intersected by a third line, that third line is called a transversal. And when I do that, I've created 8 angles, and the angles all have relationships to each other. So I'm going to draw a diagram here. So here's line K, and here's another line L. They are not parallel. And here I'm going to draw any third line that's going to go through both K and L. All right, and I'm going to name that T, because a third line that goes through two other lines is called a transversal. So I have just created angle 1, angle 2, angle 3, and angle 4. Angle 5, angle 6, angle 7, and angle 8. And first I want to introduce the names for these angles. So if these are my two lines cut by the transversal, if K and L are my two lines, interior angles are inside the two lines. So that would be angle 2, angle 4, angle 5, and angle 7. Those 4 angles are inside the two lines cut by the transversal. Now, of course, if these are my two lines, the angles that are on the outside of the two lines, those would be called exterior angles. They're on the exterior of my two lines. So that would be angle 1, angle 3, angle 6, and angle 8 are exterior. So I have 4 interior angles and 4 exterior angles, and they are related to the two lines that are being cut by a transversal. Another relationship that exists is when we look at the position, we have corresponding angles. And this is a pair of angles that are in the same position. And by position, I mean upper or lower, left or right. So if we look at this intersection point, angle 1 is in the upper left position. Positionally from this intersection point, up and to the left is angle 1. And at this intersection point, angle 5 is up and to the left. So angle 1 and angle 5 are corresponding angles. They're in the same position. Similarly, we could say angle 2 and angle 6 are corresponding angles because they are both in the upright position. And hopefully you get the ideas. Angles 3 and 7 would be corresponding because they're both in the lower to the left, and angles 4 and 8 are corresponding because they're lower to the right. So angles might be related to each other as corresponding angles. Now, the last notation I want to introduce is same side, meaning angles are on the same side of the transversal. That line that goes through the other two lines. So angles 2 and angle 5 are considered same side angles. Angles 3 and angle 8 are same side angles because they're both below the transversal. They're on the same side as the transversal. If angles are not same side, they would be called alternate side, meaning they're on opposite sides of the transversal. They're not on the same side. So angle 1 and angle 4 are opposite side angles. Angle 2 and angle 7 are opposite side angles. So those are just some notations. We've got interior, exterior, corresponding based on position, whether they're on the same side of the transversal or whether they're on opposite sides of the transversal. And we're going to have a lot of different theorems and several different calculations regarding the relationship between these 8 angles that get created when you intersect 2 or more lines with another line called a transversal. So here we have that the interior angles in our diagram, here the interior angles would be 3 and 4 and 5 and 6. They're on the, Angles 3 and 4 and 5 and 6 are inside the lines that are being intersected. Angles 1 and 2 and 7 and 8 are on the exterior. And corresponding angles are by position. So angle 1 and angle 5 are corresponding angles. So a lot of new vocabulary in this section.